really excited about our first keynote. And it's my pleasure to introduce Dr. Cassie Kozyrkov. So Cassie is an extremely unique person. She has 4 degrees: economics, psychology, neuroscience, and statistics. She is the chief decision scientist at Google, and she advises leadership on decision process, AI strategy, and building data-driven organizations. And what's really interesting is that she straddles these multiple worlds, and perhaps due to this unique background, she has created a really wonderful opening in the field of AI by coining the term decision intelligence, and which is really a way of broadening the lens and creating a space for human decision making in the world of machine learning, in the world of AI. So it's created a broad opening where decision science can make a contribution to AI. So this is a very big deal. And I want to also say on a personal note that when Cassie gives talks, she usually addresses 5,000 people, 10,000 people at a time. So for her to come to our conference, she's doing this entirely because she feels she belongs here. She feels like this is her community, and we're going to make a dent in this topic together. So we're so delighted and extremely grateful that you're giving us our opening keynote. Thank you. Welcome, Cassie.
Thank you so much for that introduction, Soumya. So I am delighted and honored to be here. In fact, when my participation was announced for this conference, there was an online comment that really resonated with me, and it was, "Welcome home, Cassie." And that is exactly how I feel about this community. Now, to me, I started with data. When I was maybe 8 years old, I discovered that Excel was awesome because you could put numbers in there and then summarize them, and that was fun. And so while the other 8-year-olds were all playing outside, I was fiddling with spreadsheets. And so to me, playing with data also feels like a fun, almost childhood activity. And then growing up a little bit, I started to think about why is this data worth playing with? Is the data important for its own sake? And my conclusion was no, it isn't. Because what we think we know about the world doesn't really matter until we act. It is through our actions that we impact reality. And so while data are really pretty, it is decisions that are important. But to make good decisions, you should use useful information that's available. And so to understand decision making, you have to bring in the data stuff, which is why I trained myself both in the decision sciences and in the data sciences. But now I come back to you to tell you that I have been a spy for you all along. Because my most recent graduate degree is in mathematical statistics, and after that, when I joined Google, I joined as a data scientist. And in fact, funnily enough, they advised me during my interview. So I actually applied and was offered 2 different positions at Google. One of them was in user experience research, more on the psychology side of things, and the other was in data science. And before my data science interview, someone suggested to me, "Cassie, don't tell them about your other stuff with psychology and decisions. Just go straight data science. Just sell yourself as a statistician." I said, "All right, fine, I'm going to try to do that." And when I got that job, I was joining as a research statistician. And I had intended to, for a while, maybe leave or put on hold the whole decision stuff. Then I started looking around and seeing how data science was actually conducted without the decision component. And I found myself slightly shocked. Things needed some fixing and needed some help, which is what inspired me eventually to build our decision intelligence training program, which I saw as an improvement of data science by bringing in the decision sciences. So an augmentation with a decision perspective. And now we've trained over 25,000 people at Google, just at Google, in this. And I'm also beginning to blog and make videos out there for the rest of the world to start joining us. So that's a new initiative for me. But when I explain decision intelligence to Googlers, the way I explain it is this. I say you can think of it as machine learning plus plus, but really, it is about reducing type 3 error. Now, what is type 3 error? Those who have taken a stats class, let's have a quick refresher of what you learned there. Type 1 error is when we incorrectly reject a null hypothesis. Type 2 error, incorrectly not rejecting a null hypothesis. Type 3 error, correctly rejecting the wrong null hypothesis. Or if you like the Bayesian statement, I know a lot of you like the Bayesian stuff, the Bayesian statement on the same is simply, where am I going, forward or backward? There we go. All the right math to solve entirely the wrong problem. And we see this a lot in data science. We see folks making really rigorous, effortful calculations for no good reason. And engineers building systems for a year, 2 years, and when pressed, why did you do this? What was it for? They can't give you a good answer. Now, this type 3 error thing tends to be mentioned in Stat 101. And there are titters. Ha ha, hee hee, solving the wrong problem. And it's presented as an emblem of hopefully working on the right things, helping take better actions with data, and then it's promptly forgotten. And so there's some expectation that we can mention it once in class, and then people go through a PhD and say statistics or computer science, and then they go to work, and then all of a sudden they transcend out of their math and start to look around and think about decisions and usefulness. What is the plan there for people to know what to do and how to do it and to even want to transcend? As we like to say in Google's Site Reliability Engineering division, this is in fact their motto, hope is not a strategy. Just hoping that people transcend out of their mathematical training and start to think about actions, decisions, usefulness. That's not much of a plan there, and that's what inspired me to want to start to train people to actually do this right. Now, what is data science? Before we get any further, a lot of people have a lot of different ways of describing data science. Some people joke that it's statistics on a Mac, or statistics for people who can write code. I prefer to think of it this way. It is the discipline of making data useful. And if we see it that way, then it would be an umbrella discipline for statistics, machine learning / AI, and of course analytics. But how do we separate all these things? And what's the difference between statistics and machine learning? What's the difference between statistics and analytics? Well, let me try a few taxonomies on. So the first one, if you are a practicing data scientist, I hope you find this as awful as I do. Some people try to split these disciplines based on the tools. Absolutely horrible split. Let's try a different common one. Based on the math used. What you should know is that if you are a sufficiently bloody-minded data scientist with a point to prove, you can use any of the algorithms and equations to any of these purposes. So this is also not a good division. So instead, the division that I propose and that I teach when I teach data science is this one. None, many, few. None, many, few what? Any guesses? See, in this audience, exactly, in this audience, you get it. None, many, few decisions. Well, I remember once giving this talk to a data science community, and someone blurted out, data points, to which I had to say, when you have no data, descriptive analytics is a little bit tricky to do. So yes, it is indeed about the decisions that we want to make under uncertainty. Analytics would be about getting inspired. We don't even know what decisions we want to make, so we want to gather inspiration. And if that is the way that we're thinking about things, then the excellence of an analyst is speed. How quickly do we run around in all these data that we know nothing about to produce inspiration? But also, as this community knows, because of the way that humans are really good at seeing Elvis's face in a piece of toast and other good pattern finding, and because we're really good at confirmation bias and seeing what we want to see, analytics cannot be taken as a serious and rigorous source for data-driven decisions. Because there, the decision is not specified in advance. Now, these other two, it's about how many decisions you want to make. If it's very few or just one important decision under uncertainty, that is statistical inference. And again, even statisticians sometimes don't realize that what our field is about. It is about changing your mind. If you are Bayesian, it is about looking at a formally stated opinion and changing your mind about that opinion with data. If you are a frequentist, you need to have the notion of a default action, an action you are committed to. That forms your null hypothesis. And then you ask, do the data make me feel ridiculous about my null hypothesis, and therefore switch me to the alternative action? And all this business about learning things about the universe doesn't quite work nicely in the frequentist framework, but the action selection does. So again, a decision-making discipline, and then this machine learning and AI one, it is about a recipe for making repeated decisions. And of course, with uncertainty, because if there were no uncertainty, we could just look at the answer up in a database. So this is my breakdown. So of course, this is very decision-oriented. And what you also realize here, since you can use the same tool for any of the three, and you can use the same equation for any of the three, the way that you should go about working with your data depends very much on your decision framework. So the person who kicks off the analysis, the decision maker, the decision professional, is the factor that determines everything else about your data science project. So what if we don't have any trained decision makers? Then you have disasters. I get asked this question a lot. And I also, when I'm talking to leaders of large companies whose names will remain unmentioned, but that you would recognize, they say this lovely sentence to me, and it is, "Our data scientists are useless." Well, why are they useless? Because what you do is you hire a bunch of PhD nerds and you put them in a room and you tell them to go do stuff. And what they're going to do is what they're most comfortable with. So I propose a cheeky hypothesis for you. Perhaps people who stay in academia for a really long time to get, say, a PhD are really susceptible to the rewards that you get in academia. And what are those rewards, especially for the mathematically oriented? You get a pat on the head, a gold star, every time you use the most complicated thing in your arsenal. Not do the most useful thing, not solve the most important problem, but where you show off your methodological complexity. So you take a bunch of people who are very excited and very reinforced by that action reward cycle. You bring them into industry, and then you just expect them to what? Contribute? Fix your business because you think that data are magic and you pronounce data with a capital D? Oh dear. So instead, what I tell people is this. Let everyone in your organization engage in analytics and treat that as mere inspiration. Look at data in a shallow and quick way. Don't take it too seriously. Don't be overly methodologically complex. And then when it is a decision maker who looks at that inspiration and says, I actually might want to make a decision based on this, or I might want to automate something based on this, then you go and you do it rigorously, and you engage in statistical inference or machine learning and AI. So the principle here, And what I'm teaching all these folks, and when I help these Fortune 500 companies with their strategy, what I'm also teaching them is analytics until a decision maker says otherwise. Until a trained decision professional steps in and actually specifies the framing of the decision that's going to require AI or statistics. Now, some pushback that I get at that point is that that's all good and well, Cassie. Where do we find trained decision professionals? Okay, that's also my question. My best attempt at that is helping to train folks and to democratize what we know about as far as I can and really cheerlead for decision intelligence and decision making, decision science. But what I think is really going to be important is for all of us to step up and understand what role we and our students and our colleagues should play in this AI future. So let me take you through then my view of machine learning. The stuff that you learn in grad school in a stats PhD or a artificial intelligence PhD is like this little red book in the middle of an end-to-end process if you're going to apply data science. And so you learn this little piece here. On the front are things like framing the decision in the first place, thinking through usability, thinking through populations of interest, all that kind of stuff, which you don't actually necessarily learn. Metric design in the AI PhD program. And then on this side, the engineering to get it to work in production, and then things around safety nets and reliability. Big end-to-end thing, and yet what is taught in most of the data science programs is just this little piece. So I think that we really need to take an end-to-end view. And if there is one community that is most qualified to think about this stuff from that big picture perspective, I think it is us in this room. So machine learning, here's my view of that. I'm cheeky. I go on stage in front of, as you said, 5,000 people, and I'll say, this buzzword that you're all so excited about, what is it actually? It's thing labeling. It's not about building humanoid robot-type entities. It is about automating repeated decisions. Decisions like, is this photo a cat, yes or no? Or how much should we bid on the next auction? And of course, it can be used for analytics, same algorithm, right, different purposes, where it merely surfaces some inspiration. A lot of the unsupervised learning applications are exactly this kind of thing. Put like with like and see if we're inspired. Clustering. Or anomaly detection. Something is unusual in the data, are we inspired? But that's just analytics. Sometimes, quite often, it is supposed to automate a business process. And it does result in the irrevocable allocation of resources. For example, if I want to serve a search result, I am fighting for limited user attention. Once I've put that search result in place, that's what the user saw. That will also influence whether the user will come back to my search engine in the future. So the most interesting and the most careful applications and the most common applications of machine learning and AI are ones that can be framed as decision making. Now, a quick note about machine learning versus traditional programming. What's the difference? Well, we need to get from information to an answer via a recipe, or model. Model is just a fancy word for recipe. And the way that it's done with traditional programming is the programmer thinks really hard about the problem, communicates with the universe, and then handcrafts that recipe, that model, to take incoming data and output answers, decisions. In machine learning, though, we don't handcraft those recipes anymore. Now the programmer's effort shifts to putting examples into the system, and it is the machine learning algorithm that does the stitching. And AI, sometimes it is thought of as a superset to machine learning, but the way the term is really used today is as a synonym for deep learning. So when people talk about AI this, AI that, they're really referring to deep learning. And deep learning is for solving tasks like this one, cat, not cat. You just took in some really complicated information through your senses, and you got the label as if by magic. How do you know that that's a cat? Can you tell me exactly what you did with each pixel to output that label? No. Our brains have had eons of evolution. We can just do this. We don't even know how we do it. And so if we think about creating, stitching, handcrafting that recipe or model, and what's going to be in that recipe? Look for oval type things, maybe triangles. Well, will it handle that situation? Unlikely. And yet for you, no sweat, you can see that that's a cat. Instead of trying to handcraft here, where you pretty much have no hope of succeeding, why not instead use examples and an algorithm that can pull out a pattern of what to do with those pixels and automate this task for you? So AI, what people are really excited about today, is about solving those complicated tasks that we cannot handcraft solutions for. But actually, it turns out that the approach is the same for whether you're doing an AI task or a machine learning task. So you don't even need to worry about the distinction, which is why I lump them together and I talk about machine learning all the way through. The essence of it is about explaining with examples instead of instructions. That is what machine learning boils down to. And we're really excited about it because we can now solve completely new classes of tasks because we have a second way to talk to computers. We used to only be able to talk with explicit instructions. Now we can speak with examples. And so that's the reason to be excited. Some tasks, we can't come up with those instructions. They are ineffable. And AI is about automating the ineffable. It lets us do more than we could before. But hang on. We're talking about really complicated tasks with really complicated recipes. Are we expecting that we can just open up those recipes and read what's going on in them and know how it's working? Not really. It'll be thousands, hundreds of thousands of lines of gibberish that our human minds can't wrap themselves around. So how might we trust a system like this? Well, I propose that testing might be a better basis for trust. And I suggest to engineers to think about this. If you are planning a trip in a spaceship and you have the choice between a spaceship where you have an exact stack of physics descriptions about how this thing purportedly flies, but no one has ever flown in it, or another spaceship, no one knows how the thing flies, but it has completed a lot of successful flights like the one that you're going on, never has had an accident. Which spaceship will you choose? I don't know, maybe it's the statistician in me, but I strongly prefer the one that has been tested. So I suggest testing as a basis for trust, testing on new data, of course. Overfitting, what they call overfitting in machine learning and AI, simply refers to memorizing the exam problems before taking the exam. How do you make sure that your student is not memorizing their way to a perfect score? Test them on things they haven't seen before. So test them on new data. And this is a statistical test, and this is what keeps you safe. It makes sure that your system works. So that's the setup that AI folks understand up to here. Let's take a closer look, a more complete look at this AI thing. If you overfocus only on the decision outputs, those little decisions that the system makes, which lend themselves quite a lot to decision analysis also, you might miss some bigger decisions going on. So I'd like us to start thinking not only about AI for making decisions, but also the decisions for making AI. This picture gets more involved. There are two phases in an AI project. The prototype phase, where we are supposed to train and test a toy thing, and then the production phase, where we're going to modify that code so that we can deploy this thing safely and reliably in production And we continue to monitor it and check it and maintain it to deal with a changing world. Analytics has different roles to play in both of these. Analytics is all about iterating wisely in the prototype phase. We have a lot of potential inputs. We can't try them all. Which ones do we start with? Which models seem to be promising? How do we tune our hyperparameters? All that kind of stuff lends itself really well to analytics. On the production side, it's about monitoring. Does this thing still work? Are there any anomalies, surprises, things happening that we might need to react to? Now, unfortunately, a lot of companies fail horribly at analytics because they miss a really important point. If we don't know what we're looking for in advance, then we cannot tell the analysts to go find a specific thing and make their mandate the looking for something specific. That makes sense, right? So what you have to do is give analysts an allotment of time for exploration. It is a time investment. Now, how do you think about the decision to invest some amount of time in exploration? Well, it turns out that most business leaders have no idea how to think about that. You know who does? People in this room. What about statistics? Statistics in both cases boils down to, does it work? Because it's all good and well that you try to build some machine learning system, but if you want it to work, you're going to have to test that it actually does work, both in prototype and that it continues to work when it is out there working in production. So we've said testing keeps you safe, and to some extent, the data science community gets this. And there's some data science groups still in their infancy that confuse all three areas of data science, and they think that analytics is actually statistics and all kinds of other horrible things, and they don't split their data, and it's a delight. But to the extent that the data science community is maturing, they kind of get this thing. You have a pristine allocated test data set. You check that your system passes that exam before you release it onto the world. Now, here's the part that a lot of them haven't thought about. Who sets the exam? The only guarantee, once the system passes testing on new data, is that it works according to whatever the exam was. Who sets the exam? Who decides on what data, on what textbook problems the student must pass? Who decides at what quality that exam must be taken? How many questions must the student ace? Who decides the metric? Even if it's cat, not cat, we've got lots of different options, from precision to recall to accuracy to F measures to all kinds of things. Who picks that performance metric? Who's qualified to do that? You know what happens out there today? Like that. Just, they make it up after the fact. In fact, even worse, I'll show you an order of operations thing. In both of these phases, we should be asking what it means to work. That's for decision professionals to do. And there are 4 decision points, major ones and lots of other little ones. Should we attempt it in the first place? And how do we think about scoping machine learning projects? Should we productionize it? When it passes testing in that first block, it's not set to run live yet. And it has not been tried on live data, and it might influence later on the world that it exists in. So the decision to actually invest engineering resources to building it is a separate decision from, should we launch it? Should we release it at 100% to all of our users? And if the world changes and the data changes out from under us, should we keep it? How do we think about these 4 decisions? And what I'm not seeing anybody talking about, except insofar as this community and my own work, how do we be formal about these questions? I want to also tell you what goes on there, in my experience, in applied data science in industry. What order do you think people do this in? The order of their comfort zone, again. If you have a PhD in algorithms design, that formal AI research PhD, you think algorithms first. So you're like, neural networks, they're cool. Where can I find some data to apply to these neural networks? And then, as an afterthought, where in the business might I shove this system? You can see there might be some dangers there. If you're an analyst and you are first and foremost in love with data, you think first about the inputs. What data do we have? Then what algorithms might be cool? And then again, as an afterthought, what are we actually serving? But you know how to do it better. You know that where we start is with the outputs. Don't worry about how the system works in its guts. What are we serving? What are the right sort of outputs? And if mistakes happen, which mistakes are how much worse than which other mistakes? And how do we score the whole thing? And how do we set performance criteria? That's this community. And I'm not seeing a lot of this out there in the world, and this frankly scares me. Now, some stuff that we know here, we need to set performance criteria in advance. Out there, quite often you build the thing first, and then afterwards, you see whether you might feel like launching it statistically significantly. Now, what we over here know is that sunk cost fallacy is a thing, right? And humans, after pouring 3 years of love into a system, will begin to bargain with themselves and say, oh, but the performance is not so bad. And then before you know it, you have some poisonous rubbish running around out there released. So you have to do this in advance. Setting performance criteria up front. That also means that you need a decision professional, a trained decision professional, up front, early on in the project, to kick this whole thing off. And when you create your metrics, you need to think about creating metrics which, if they were passed in testing, would mean that you actually want this system to exist. So that it is your metric means that both the spirit and the letter of your wish are fulfilled by a system. This is one that, again, the data science community is not very good at, but I think this one knows a lot about. And then I want to leave you with this thought in the last 2 minutes. Which of these is better? A reliable worker or an unreliable worker? Any thoughts? If you're saying reliable worker, definitely, 100%, I'd say careful. It really depends. And it depends on the quality of the decision maker. Because a reliable worker will scale up an intelligent decision maker's wishes. But if the decision maker is unskilled and foolish, then it will be like those coffee shop signs. Caffeine making you do stupid things faster. If we have a bad decision maker, we don't want reliable workers. We want diversely unreliable workers, humans, who will go and do their own thing in all kinds of different ways, and they will mitigate the effects of this untrained decision maker. Now, here's the scary thing, and here's pretty much why I do what I do. So I realized this, and then I was terrified. People are scared of AI for all the wrong reasons. The reason you should be scared is that technology is a lever for the decision maker, the human who is deploying that technology. AI is the ultimate reliable worker. If it passes testing, it will do exactly what you asked it to do. And it will do it at scale. We are amplifying, with big data technologies, we're amplifying the human decision maker. We're allowing them to have massive, outsized impact on the world. And sometimes that decision maker doesn't even realize that they are wielding a lever this big. They think they've got a team of magical data scientists and everything will be okay. Whereas actually, this is one human, amplified hugely, able to impact everything really quickly. In the past, bad decisions were self-limiting. It was only kings or generals who could have that much impact on the world. Whereas Whereas the rest, whether you made good decisions well or poorly, you would be okay. But not today, not with these tools. That impact is growing far too much. And yet we are not training decision makers. Which is why I want to appeal to this community to realize just how important you are as the starting point, step one of all of this stuff, because the world is headed towards big data technologies. We will have an AI future. And I see AI as the proliferation, if you will, of magic lamps. It's never the genie that is dangerous. It is an unskilled wisher. A wisher who does not think through what they are actually asking for. And there are a lot of myths in humanity's stories around silly wishes that then have dangerous consequences. Bad decision making, amplified to come back to bite you. This is the future that we are moving in. We need to make sure that we have trained a new breed of worker. The decision professional who can work at the first stage and throughout the entire project. So I hope that you are excited to feel like you should come into AI and make that community recognize all the wisdom that you have been gathering over the past 25 years. Because hope is not a strategy. Just hoping that humans are going to learn how to make decisions wisely, work with these big technologies, that's not a good plan. So let's be more thoughtful about this. Let's all work towards a brighter future with good decisions amplified by these technologies. And if you know of any decision makers working in AI, starting projects, I have a blog post that is an 18-minute guide for things to think about step by step as those people are starting out so that they don't hurt themselves. So that can be found at this link, bit.ly, Quasita, which is my Twitter handle, _DM or decision maker guide. This stuff is really important, and I'm really excited to be home with this community. Because I think that tomorrow's AI will be built on what we here do today. Thank you very much.
In this community, we rely a lot on uncertainty, and uncertainty is not to be found in any database. How do you reconcile the work of AI, which deals with data, which is past and present, with thoughts about the future, which is the realm of uncertainty in which a lot of us spend significant chunks of our time?
It would be an interesting question statement. The idea that uncertainty is not found in any database. When you really don't have any uncertainty, you do not need AI, because what do? You look the answer up. That's what you do. When you, for example, need to automate something like output the correct social security number that goes with this person's employee ID, what do you need pattern finding for? Just look up the answer. The requirement to find patterns and make recipes out of them so that we can deal correctly with future data is fundamentally about uncertainty. We only need AI if we have uncertainty. But now here's the thing. We've got all the data that we are using in the prototype phase is essentially a sample. The population is the data set in which we're going to need to serve this system. So we are in some hardcore statistical thinking here. We, as the decision maker, have to think about designing that exam in terms of what is the population, what is that data set, the full one that I expect to serve my system in. How well does my sample, the data that I have access to in my database, actually cover where I need to serve my system? What assumptions am I willing to make? Again, statistics is not magical magic. It's about taking assumptions plus data and coming out to a reasonable course of action. So what assumptions am I going to be making? And if I'm wrong about these assumptions, and some sensitivity analysis stuff, how bad could it go? Fundamentally, uncertainty is in. And what we think about in this community in terms of uncertainty is definitely also in there.
We have lots of great questions coming in, and I'll just mention that Cassie wanted to actually talk to people one-on-one, so please feel free to ask her questions in the break. I will just ask you the top voted question here in the room. How do you reconcile ethics in artificial intelligence, and where do you inject it?
And what's the last bit?
Where do you inject it? Inject
Where do
ethics.
we inject ethics? So, what's that nice way that Ron Howard puts it? Decisions are amoral, not immoral. The ethics must come from us. And when I say us, I am referring to the decision maker for the project. Just because you can build something doesn't mean you should build something. And in fact, if you don't think about what you're building and why you're building it, you are most likely to end up building something that you shouldn't. But when you are deciding whether this system should exist and why it should exist, that is the place where you are injecting the ethics. And when you are thinking about which populations, and you should think about 3 types of populations, by the way, the data population, the intended user population, and the entire potential user population, the people who are affected but may not be direct users of your system. When you are thinking about who those populations are and how you're willing to trade off performance across various aspects of those populations, you are injecting ethics in there. When you say something like, oh, well, our system right now, we only have data about the US. Our system is going to launch originally only in the US, so we have a decent sample for that population. But later we might expand globally. You're also making the statement that you are quite happy to then relatively fail on the global scene because you have preferred information, you've limited yourself, you've biased your system with respect to a global population, whereas you might be unbiased with respect to a local population. All of that is down to the decision maker. All these little assumptions and settings, they are themselves subjective and the injection of ethics into your system.
Thank you so much, Cassie. I know it's not just me. You would have guessed this by now. She's keeping tabs on our community. She knows a lot about what Ron Howard has said, and not only that, she's going to lead 2 panel discussions tomorrow in the high-tech track, and she's co-chairing the track. So she's not just here as a keynote speaker, she is a part of our story. So please talk to her in the break with your questions, and also feel free to use the cards to talk to each other about data science. So with that, we will reconvene at 10:05. Yeah, so 10:05. We'll see you back here. Thank you.